Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland. Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en met wie zit ik ook alweer?
Met Jan Stompost.
Oh, ja, tuurlijk Jan.
Ja, van ACC ICT.
Ja.
Je kent hem wel.
De enige echte. Hè?
De enige echte. Nee, we zitten hier, we hebben onze hele eigen ruimte gekregen.
Hebben we weer goed geregeld.
Dat hebben we goed geregeld. Dus, we hebben 2 gasten dit keer.
2 gasten. Eentje is spontaan aangeschoven, althans spontaan.
We like spontaneous extra people.
Yes, spontaneous extra people. That's Rodrigo Kuntzer.
Exactly.
And Andre Mocke.
Yes.
Welcome. I will start with Rodrigo. Can you please introduce yourself to our listeners?
Of course. Thank you, Jan, and honor to have us here today. So my name is Rodrigo Kuntzer. I'm I would say SRE and DevOps engineer working for Miro. And I have been working with Kubernetes and cloud-native technologies for almost a decade by now, especially I would say with Kubernetes since 2016, starting with Kubernetes 1.4 back then. It was really challenging, I would say, but things started well, and looking back to a decade of using it, it's impressive how it grew from there on. You know, I joined Miro 4 years ago, where my official title is a staff SRE engineer for our cloud infrastructure organization. Pretty much focus on everything related to infrastructure experience for our developers and for our product engineers. Things related to CI/CD, infrastructure as a code, and of course related to our compute platform as well. We adopted Kubernetes back in 2021, so we are pivoting into 4 years of Kubernetes usage at Miro. And that's, I would say.
And how did you get started in the IT? What was the thing that got you motivated to start a career in IT?
I see. Yeah. So my background is as a software developer. I started back, I would say, when I was a teenager as a, let's say, doing pet projects and also helping my family with their business in terms of building some solutions for them. And then it became a career later on. My large background is in the JVM space, most related to Java and other languages around it.
Java.
There we go again. Don't mention Java. We need to make a side note before we start interviews. Don't mention Java, otherwise you always get the heap question.
Yeah.
That's a running thing at the moment. We should make a new shirt.
Oh yeah.
What about the heap?
The thread dump as well, you know. And then, of course, as I would say, moving to more technical leadership roles in the Java space, it was natural to start touching infrastructure-related topics, and then Docker came along, I would say, in the beginning of 2012, something like that.
Okay.
Then moved those workloads into containerized environments. Then cloud came along as well. My focus so far is pretty much on the AWS public cloud, and then Kubernetes came along, and then now I would say, even though I like to touch the development side of things from time to time, especially more focus on helping our product teams in terms of performance-oriented stuff and so on. I would say that now 100% of my time is dedicated to be an infrastructure engineer.
Okay, nice. Cool. And Andre?
Yeah, thanks. First of all, Ronald and Jan for having us, and Rodrigo for letting me invite myself along. Appreciate that. I guess I have actually not a too dissimilar story than Rodrigo. I also started as a product engineer primarily in the Node ecosystem back then. This was about 10-something years ago. I come from a rural place in South Africa, so we worked with farmers and built a lot of like bespoke things for them back then, alongside some of the other local stores and stuff. So very front-end focused. And then throughout my career, I moved further and further into the back-end. And when I joined Miro 4 years ago, was around the same time as Rodrigo. He was our embedded SRE on the team. I was one of the product engineers, and he just absolutely blew us away with like the breadth of and depth of his knowledge. And I made a bunch of career decisions at Miro to start creeping closer to working with him again. And that's where I ended up this past year, is like with his team. And big part of the reason why we're here and presenting at a KubeCon.
Yeah, and joining us in the podcast. So
exactly, it worked out well.
It worked out well. Yeah,
Awesome.
Awesome. Yeah. Hey, you guys have a talk here. You already mentioned it. It's the title is draws attention because you talk. It's stateful connections and the scaling secrets no one talks about. While scaling and stateful is definitely a thing people, talk about, but not maybe not the secrets. Can you tell us a little bit about what your talk is about?
Of course. So, just to provide a little bit of context, where Miro actually uses stateful connections and stateful workloads regarding to what we will talk on Friday. You can imagine Miro as a game engine for the enterprise, because our product positions itself as a broadly collaboration platform for enterprise usage. And because of that, we aim to provide real-time collaboration interfaces for, I would say, hundreds of users to join into a Miro board and work in a real-time fashion there. So it pretty much means that we have in our backend one of the components, and the most important component of the backend is what we call our board server, which is a stateful server where every user on a given board needs to be connected to, more from things regarding to performance oriented and low latency when communicating between each other, right? And that introduces some considerably challenges from routing at edge perspective, right? So how, for example, browsers or devices will get to be connected to a specific server, So our protocol of usage, because we are pretty much a web or a browser-oriented platform, is to use WebSockets for this type of connection, right? To allow bidirectional message to be exchanged between the browser or between the client and the server. Mm-hmm. And on that regard, we have one component of our infrastructure, which is our reverse proxy for WebSockets, right? So this reverse proxy is what allows or has the intelligence to route the users or a given socket opened by the clients to a specific board server.
For our listeners, can you explain the WebSockets?
Of course, and that's one interesting part that we are actually going to cover there, because before you dive into any web stateful implementation, you need to understand the game you are playing, right? Mm-hmm. One of the important things is understanding the protocol you are using. So WebSocket is an extension of the HTTP 1.1 protocol, so it works, I would say, similar to any, at least in the initial part of the request, it behaves exactly like when you are going to perform a RESTful API call from a given client to the backend. But during this process of establishing the connection or establishing the initial request, there will be some special headers, of course, the client will be sending to the server. And then there will be a handshake process that will upgrade that initial request to a WebSocket connection. And once this handshake process is done and the connection is upgraded, we pretty much get what I would say a long-living connection between your client and your server over a HTTP request, which is the go-to protocol or solution used when we are talking about, I would say, front ends and web interfaces interacting with a backend.
So you, as a client, have a direct connection, open connection to the server.
Exactly. And then both have, let's say, a channel that they can send message between each other. If the client wants to send something to the backend and vice versa.
But that's a stateful connection.
Exactly.
Andres is smiling here.
And that's not working on Kubernetes that good.
Well, exactly, and that's, but unfortunately that's a requirement from our product, right? And as we are in our path of consolidating our runtime towards Kubernetes, we have to find our way around of playing along with those limitations. Do you want perhaps to join us?
Yeah, like the only thing I wanted to add to Rodrigo's sentiment is like we're a game engine, but we get sued if we lose data. So there's a little bit more risk to it as well. So we need to make sure these things are as reliable as possible. We cannot, as he mentioned just before we started recording, he mentioned we can't treat these servers like cattle. The state on the boards are important.
And then circling back to Kubernetes and stateful, along leaving stateful connections there, I would say it's not really that Kubernetes doesn't play along or doesn't play well with that, because I would say from a network perspective or from a network module perspective on a Kubernetes cluster, especially in our case, you use Amazon EKS and the AWS VPC CNI, which provides you a flat network for our pods and so on. There is nothing that I would say behaves differently if you would keep a simple EC2-based deployment, but of course, it introduces more challenges because pods, even though if you don't treat them as cattle, and in this case, we treat them more like pets and they are precious for us, you still will be disrupting them more frequently, or because you want to rotate your nodes, you have some compliance related to that, right? So our take on that is that we have built, or we moved from an open source solution regarding to this reverse proxy for the WebSocket connections. Initially, Miro was built using FabioLB. I don't know if you have heard about that.
Not me. No.
It's a pretty nice and cool project that provides a reverse TCP and HTTP proxy similar to Nginx or Envoy or anything like that. The interesting thing for FabioLB is that it can be, you can dynamically update its routing table based on HashiCorp Consul service discovery. So our initial take a few years ago on how we implemented that is that once a board server come up, it will advertise themselves into a console using a console agent, and then the FabioLB will automatically know about that new server, and we automatically provide a path-based route at edge, because FabioLB was sitting at edge, that would provide a direct path to access a given board server. So the server, the board server pretty much became known from edge, and clients could go straight, for example, miro.com/ws/the name of the server, and then they could go and connect straight there. But this is a stateful routing system, right? So if you lose a server to backend, there is a lot of concerns regarding to that, to renegotiate and get the client to know about the new server that would be responsible for their reward, and from a security perspective, it was also not nice because you're disclosing the name of your servers to the public internet, And even though that Fabio is a great product, it was lacking some deeper considerations regarding to stateful nature of WebSockets or long-living connections in this case, because as any reverse proxy, we were scaling up and down that pool of servers during the day, and especially when we are scaling down, and we have stateful connections between your clients going through that proxy, it's introducing challenges in terms to notifying those clients that that connection will be abruptly closed just because we are scaling down the pool just to save money and things like that, right? And Fabio didn't come with any of those nice mechanisms of graceful shutdown as you really need when you are dealing with that. So our take on that was to replace Fabio and build an in-house solution for WebSockets reverse proxy. Not only to provide those nice semantics in terms of graceful shutdown, but also because there was other product-related needs for that. But one of the, for example, when you talk about WebSockets, one of the well-known limitations regarding to that is that browsers has some sensitive limits in terms of how many WebSocket connections you can open to a given domain or hostname and so on. And as our product grows, not only in, let's say, from a perspective of a board where you go and put some stickers, but we are positioning ourselves moving forward as a 360 platform for workforces collaborating in real time. You have the need of, I would say, initially to open more WebSocket connections to different backend systems in our backend, but that would easily bite us from a browser perspective, right? So the solution in this case, and that's another great benefit of having our own reverse proxy implementation, is that we could get what we called multiplexing done in our backend. So now you have a single entry point for WebSocket perspective, but internally our gateway has the ability of multiplexing, connecting connections to different backend systems.
That's awesome.
Yeah. And then we mitigate the possible limitation that we would face on client sides, and still give freedom to our product teams and teams building real-time collaboration systems in the backend to allow them to have just different numbers of connections to the client. Yeah.
But multiplexing is a bit slower then. You're sending all the data across one connection.
Yeah, of course, it comes with some implementation details on that on that side of filtering and knowing where to which I would say backend side connection it should be going to, but a part of that I'd say it's pretty much a low level filtering and routing thing on the gate.
Okay, so you solved the WebSocket to the clients thing, and you've built your own reverse proxy. But still, we've got containers on that Kubernetes cluster who have stateful connections.
Yeah.
And how did you solve that?
Talk about that.
Yeah, like I don't want to give away all the secrets of the talk later, but we started by making a lot of mistakes. That's why we're here. Okay.
It's not the podcast will go live later on, and not everybody will attend in KubeCon. So
okay, well then we can give away the secret. So
thank you.
thank you.
It came down to, like, from our perspective, three things: like graceful shutdowns, being intentional about how we handle the pod shutdown life cycles with the component that sends traffic to them, in our case the ALBs, how we're scaling up and down, the horizontal scaling, and then how we're balancing the connections as well. Because if we're thinking about traditional, or I want to say conventional strategies like round robin, and we have long-lived connections, your old pods start being overloaded if you just keep sending new connections to them and things. So we needed to think about those three things and how to get to an optimal solution for each of them. So on the graceful shutdown, as Rodrigo pointed out, from the application side, it was made from the start to be clever and let clients know that, we're going to start draining your connections now, so that the clients can transparently, to the user at least, connect to a different pod in the load balancing pool. So that was one fundamental important thing. And then also just the timings of how we register and unregister the pods into the load balancing pool was important, because like if you, for instance, drain a connection, but the pod is still in the load balancing pool, that connection could very well just open to the exact same pod again, and then the pod receives a sick term and everything drops. So we needed to intentionally tune our timings so that we know we take it out of the load balancing pool, we start draining connections, the client will receive the close event, so it will open a new connection, as an example. On the scaling, Rodrigo had the foresight to introduce an operator called KDA that we use for event-driven auto-scaling, and it gives us a very easy way to tap into the amount of active connections. So any pod would emit how many active connections it has, which is a very great way to manage saturation for a proxy, where the work that it needs to do differs wildly on each of the connections, because some would imagine you have 100 users on a board all creating a bunch of different things, or one guy drawing a picture for himself about what he wants his house to look like or something. There's vastly different of data packet sizes and frequencies that the traffic on these connections flow through. So we decided to maintain or keep the saturation levels low by limiting the amount of active connections, and then we could horizontally scale based on that. Also learned some interesting things there that I'm sure Rodrigo can tell you about. And then finally, on the load balancing pool, like we're a AWS house, so from the AWS load balancers and the target group configurations, we essentially had the two options, which were round robin and least active connections that were viable for WebSockets that we could use. And I started very proud of myself explaining why we should use least active connections, published it widely to everybody involved in the project, explaining that round robin is going to overload. I drew diagrams, very proud of myself. And then as soon as we rolled out the first version of least active connections, our new pods got absolutely smashed with like 4,000 requests per second. And they weren't warm. And our latency spiked through the roof. So we needed to come back and like figure out how are we going to either solve this slow or cold start, or how can we mitigate the old pods being overloaded with round robin. And essentially to solve the cold starts, we would need to warm the pods, like the cold sides, maybe pre-open some connections, which could be done, but it requires a lot of intentional work on that.
It's complex.
Yeah, it is quite. And the other thing is, AWS, the load balancers do have a configuration option for slow starts, but that doesn't work with least active connections, unfortunately. So we went back to round robin, and we're like, okay, how can we stop the old pods from being overloaded then? And essentially, on the application side, we have readiness probes on Kubernetes, right?
Yeah.
You've got readiness probe.
His legs were already shaking. Like I wanted to say it. I want to say it.
Yes. Now, this is very, very, very important, because like the controller that we used to register a pod in a target group is the AWS load balancer controller, and it works very interestingly. Like if we respond with an on200 code to the readiness probe in Kubernetes, it will be taken out of the Kubernetes services load balancing pool. It will be removed from the endpoint slices, and the load balancer controller will actually start the draining sequence from the load balancer, which means all the existing connections also gets killed.
Oh.
So it's not just signaling, I don't want anything new. It's also bye-bye existing ones. So we ended up splitting the probe, or splitting the endpoint, so that the load balancers can probe one path for new connections, and Kubernetes can probe one for its normal readiness probe. And that allowed us to signal to the load balancer, we're not accepting new connections right now. Please try again later.
But won't deregister the pod.
Yeah, they won't deregister the pod at least. So it would go into unhealthy state, but it won't start draining. But we continuously signal ready to Kubernetes because our traffic wasn't actually flowing over Kubernetes. It was coming directly from
from the load balancer.
Exactly, yeah.
So awesome.
Yeah. So, what kind of companies are you find your company or your solution is built for? What kind of companies are that?
What are the customers?
The customers, yeah.
Yeah.
Well, that's an interesting question. I would say pretty much everyone.
Yeah, of course. But do you have a specific solution for different use case?
I would say it can start from small companies or even one man band kind of company, and then grow up to. I guess we are proud to say that we are present in 99% of the SAP 100 companies, something like that.
Yeah, like
Nice.
Apple. We have a bunch of the big names proudly on our website that unfortunately I can't remember now. So please cut that out later.
Yeah.
But yeah, it starts with Apple, AWS, and all big players in that sense because there's a big demand in terms of visual collaboration for the enterprise. But as I said, not only for enterprise, it could be also for example, for cloud engineers just want to work as a contractor for some other company and wants to draw a AWS diagram of the solution or a Kubernetes diagram in a board because we do have, for example, AWS calculator built into our product these days to help driving cost reduction projects and things like that. But of course, our product, let's say from a go-to-market perspective, it's important for us to target the large enterprise, which will bring hundreds and or thousands of license to the product, and then from there we have many, not only let's say from what the users see when they are working on a board, but we have many other systems working in the background related to data triage, permissions, all related to who can see how you audit and the features, for example, related to what we call the enterprise guard in terms, for example, how long a board will be stored, if a company can, see audit logs to who had access to that board and all. I would say the enterprise suite use that comes along with such kind of product.
Yeah, because we skipped over the part, I think, because not everybody knows Miro because we went directly into the tech stuff.
Of course.
So, Miro, just in 2 sentences, can you just for the listeners who don't know Miro yet, explain to them what is Miro?
Do we each get 2 sentences or?
I don't know. It's the same. It depends how you use it, right? Or
I think Rodrigo explained it very well. It's a visual collaboration space as well. Like we're positioning ourselves as an innovation workspace. It's where teams of different disciplines come together and they can see work in real time being done on the board. Like he pointed out, we have diagrams, there's project management that happens, there's presentations, and all of this is starting to happen in one place on our product now.
That's an board like where you
Scrum board.
Yeah, Scrum board.
Something like that.
It's like a whiteboard. It's like an infinite canvas that you can pretty much, zoom in and out and add as much content as you want. But of course, you can also break it down and organize it in different things, different ways depending on your content as well. One interesting feature that was added last year is that now we also support, for example, tables and documents. So you can pretty much write live like you would do in any other, for example, Microsoft or Google Docs-oriented solution. Mm-hmm. You have that built-in rights at the Miro core platform, which is our infinite canvas or our whiteboard there. So you can use that for documenting your process, writing text specs and so on about anything that you are working. You can also, let's say, to do not duplicate source of truth. If you want to embed a document that was originally created in one board, you can sync and, let's say, create a copy of that in another board just for the sake, for example, for a presentation or for my enterprise C-level review, but the source of truth is still linked to your original source, so you can keep editing it there, and then it automatically reflects in the other places.
So and now connects why you need stateful connections, because more than 2 people or 3 people are looking at what 1 or 2 people are creating and changing.
Yeah, exactly. Yeah. And many users run, let's say, full workshops with 500 users on the boards, or Teams retrospective with hundreds of users. And then everyone is actually invited and encouraged to be collaborating there in a real time, like dropping stickers, sharing their moods, and
yeah.
Oh, that's we have to have a board also. I'm doing my mood here.
Mood board, right? Yeah. Okay, guys. Thank you very much. And we also have a final question, and I will ask them to both of you. It's always, how do you see the future of Kubernetes, and probably in combination with Miro? So,
Shoot.
Shoot.
I was hoping Rodrigo would go first, so I can steal some
I saw the look in your eyes. I think it will surprise you.
but now you can use everything that's already prepared that you're going to say in our talk, and then
now
I'm
you
going
can't
to
copy
the
me.
left.
Yeah.
Wipe the grass off.
Empty hand here.
For his feet.
I'm not going to try and steal his content. Like, from my perspective, I think one of the biggest strength of Kubernetes is the open source community and the composable nature of it. So, which means it makes it incredibly flexible for whatever our needs will be. And like